Are you from 5, lower state or opposite, and you're having problems with algorithm? This is a video for you. This is the algorithm we are mostly talking about. Algorithm. Basic syntax of an algorithm. My name is EMMANUEL-LEWIS and I'm a software engineering student, year 1 at EJET. And at this lesson or this video, we're going to be dealing with algorithm from the basic level to the more advanced level. So follow me on, let's do it together. Okay, so actually, what is the algorithm that I'm mostly talking about? So now, I'm going to answer that question with this little stitch. Imagine if you are given a task to boil 5 liters of water. So what are you going to do? I think first step, we're going to be talking about step 1, get the pot and place it on the fire or gas, whatsoever it is. So step 2, you have to get the water, right? Get the water and 5 liter. Get the 5 of water and return into the pot. Okay, now step 3, you have to put on the gas or the fire. Put on step 4, let's say you have to wait, let's say 5 minutes. It takes 5 minutes. Wait, let me see till up to 5 minutes. And step 5, off the gas or off the fire. So actually what happened here is, if you follow this step, you obviously know how to boil water. I know some of you guys don't know how to do it. Now it's another tutorial in another one. So if you follow this step, you obviously come to a solution, which is hot water. So now, what is an algorithm? Okay, everything has a characteristics, especially us humans. Characteristics of a human being, we eat a lot. So now, what are the characteristics of an algorithm? The first one we have is it should be precise. So you should know which step to take and how it should be. So number 1, it should be precise. Secondly, we talk about it should be correct. So actually, you not make an algorithm for you to boil a pot of water, and at the end we have a dry, or let's just say we have a pot of chicken. It'll be nice, but that is not actually the problem you wanted to solve. So it should be correct, and you should solve that problem you wish that you should solve it. Something like that. And obviously an algorithm should be efficient. I think let's take for example that same project or that same boiling water project we had. So now imagine if now the first step was take a pot, and place it on the fire. Second step, take 1 liter of water, put it on the fire. Third step, boil, put on the gas. Fourth step, in fact, just follow the same steps. But now I bought only 1 liter. So now take it over. Do the thing to have the second liter, do it again, or to have the third liter, do it again, or to have the food, and do it the last time at the feet. So now these two programs, the first one I wrote and this one I'm just explaining, can solve the same problem. We'll boil exactly 5 liters of water. But this second one I'm explaining is going to be more long. So we're talking about it should be efficient in a manner. Like it should be like it requires less time to do more. That's being efficient. Like if in smaller amount of time you do more or high amount of work, you are being efficient. So that's just it. Number 4, I think it should be general. An algorithm is supposed to be general. You can say you're taking that same example. Let us say you want to boil 5 liters of water. The formula should not be different from wanting to boil 5 liters of juice. I mean, your algorithm should solve every specific problem. If your algorithm is supposed to add two numbers, 2 plus 2, and now the place in the algorithm 3 plus 2, and you cannot do it, that algorithm is not general, and that is not the one of the characteristics. In fact, there are many different characteristics. And actually, we have
Guys, I'm
finiteness.
very
An
sorry
algorithm should have
about
an
this,
end,
but
an algorithm should have
why
a
the
beginning.
technical
Like,
issue
it
was
should start somewhere and stop somewhere.
and I did not know the volume actually cease. But anyway, I'll still try to explain what I was trying to say. There's no way I'm going to go back and record or we see the same things. Okay, so actually, I was trying to describe an algorithm or give advantages of an algorithm. An algorithm is very important, especially if you're doing programming. This is the reason because an algorithm is like a general language. Every programmer, no matter the programming language you're using, can use an algorithm. So an algorithm is like the backbone. Let me take for example us being in Cameroon. In Cameroon, everybody knows English and French. There is the backbone. Now the programming language can be for example, can be compared to our mother tongue. So you can listen to something in English and in French. Even guys who don't actually speak the same mother tongue, like who don't use the same programming language like C or C++, do algorithm. When you know the algorithm, you translate it now into your language. Now you can translate it in form that you can be capable to understand. So it is very important, and you really need to grab this aspect. Actually, algorithm has many different importance, but we're not going to be dealing with that now. We're going to continue. So if you're really doing software engineering, I really be a pleasure for you to continue algorithm. So now we're going to be dealing with now the structure of an algorithm. An algorithm has very structure on how the algorithm is designed. So firstly, as I was writing on the board, the first thing we have is the algorithm itself. I don't know why they always put algorithm. You write algorithm. Now you give the name of an algorithm. If your name of your algorithm is book or any question, anywhere it is, I mean, the name of your algorithm should reflect the question you are trying to solve. If actually like the first program algorithm was to boil water, we can give the name boil water to algorithm. So after algorithm, what we call the declarative part. The declarative part here will write the variables, the constants. I mean, they declare what we are going to use in the algorithm. We're going to explain variables and constants as we move forward. And after that, we have the begin. This is actually where the program starts, and this is where we start doing the programming. Now we have the body. After the body, now we have the end. So as I was saying, the main program there is at the body part. After that, we have the end, and the end is with a full stop. So now, as I was pointing everything, variables are very important because that's where we actually store the values we're going to use in the program. And we also have constant. Constant is like something that does not change throughout the variable. Like for example, the value of pi is a constant because it will never change. It is 3.14 something. So actually, as I was explaining, why am I talking too much like that? I was still explaining the same program. So now, don't forget to have semicolons at the end. Oh, not every line of code has semicolons. Like at the end of the algorithm, we have semicolons at the end, and we have full stop at the end of the program. Anyway, I also made a mistake while trying to solve the problem with naming a variable. So I think I'll do that. So as for now, let's go straight into variables because I've been talking about variables and actually have not explained it. So now I'm going to the board. Variables are like containers kept aside to store values that are going to use them in the future for future. Like for example, those 4 containers I drew there. Now take for example that these are containers in your own house and you have to store a particular item in each container, liquid. Like for example, what I'm going to name the first container, which is the first container, I'll name it container W, and there will be storing water. Second container G, there will store juice. Third container P, there will store pap. I don't know why I bought pap. That's what I don't know. Next container B, there will store beer. I think from here the volume is going to be back. So if you want to store your value where you want to store it, you put it there. I think the volume is back by now. So see you guys.
go to the container J and get his juice to drink. Every time you want to drink water, you go to container W and get the juice, the water to drink. And every time you want to drink beer, B. Every time he wants to drink pap, P. So now, according to this, variables are like spaces or memory location where you're supposed to stock information that you use for later. So now, imagine if your father wants to drink beer, he cannot come and find beer at container J because container J is kept only for juice. So now, even if your father gives you juice to go and keep in the fridge and you have to turn it inside these containers, you have to come look for container J and fit it where it is going to go. But I'm not seeing you trying to fit juice inside beer. Actually, from the bird, you see, a variable is a storage location or a memory location with a symbolic character or letter which contains some known or unknown qualities or quantities or whatsoever it is. So now, for this example that I gave, these are variables. As you can see, storage locations, like they are kept so that we should store those specific things, we kept them there. And you can either know what is inside by saying it is juice, or you don't know what is inside, just keeping it for a specific location. Your father just say that this is a container, we'll keep it, and when the time comes, I'll place whatever I want to place inside. We don't know what is inside. So now, as I said, having specific symbols so that we should identify them. Yeah, that's just a variable. How to name our algorithm, our variables, sorry. Okay, while declaring a variable, naming it is very important, but naming a variable needs to be in a way which you yourself will understand, and whosoever is around you who does not know the program, who knows algorithm but who don't know what you are trying to do, understand. So now, okay, talking about the variables that separate. Okay, talking about the variables, that different types of variables. I mean, like 4 different main types that we're using. What the first variable which we're talking about here, we'll call them integers. Integers here stores every number, negative or positive, as far as it's not decimal point included. So from, let's just say negative, infinity, -2, -1, 0, 1, 2, 3. And secondly, we have what we call the real. Here, this real stores every number, negative or positive, making sure they are decimal, 0.1, negative 0.1, negative 0.0, negative, 1.0, 1.2, 1. So it stores every number inclusive that they should be having a decimal point as far as they are decimal number. And thirdly, we have a character. Character stores every letter A, B, C. And fourthly, we have what we call a string. Strings are like combination of characters. When you combine characters together, it forms a string. Like for example, my name, Lewis, is a string. So all these are types of variable. You cannot, take note, you cannot store a string in a character because computer allocates every variable has its own memory space. Let's take for example like that. Computer allocates string to a particular number, I think it's 8-bit. Character, I think it's 201. Real and integers. So you cannot take, since I was talking about containers, you cannot take juice and mix with beer. It's not possible. It's not going to give an adequate mixture. Okay, lastly, we're just going to deal with the basic syntax of an algorithm. Basic syntax of an algorithm, where we have to receive the number, what we call print or read or write. Then you put in the semicolon, write whatever value you want, and you close. So now, what does this do? Actually, this print or use write, it actually displays what you require on the computer. So whenever you're on the machine, what you see the hello world or whatever message you see on the machine when you're on the machine is what is inside this braces here, value. So for example, if you are a programmer, when you write print, the value inside these braces is what the user of the program is actually seeing. Now read, sorry, scan or read. I give it value. Actually, scan or read stores the value of the container. Let's take for example, if now in the container that you're supposed to keep juice, all you do is you ask the user, where should I keep that variable? Let's say your father came back with a liquid. Ask the user, where should I keep the variable? The user asks you to go and keep it in the container, in a juice container. So you carry that. This location here is the place where you're keeping it. You are scanning, I mean, you are storing it in the machine where you're going to go and keep the value you are going to use. So when the user enters a value, you have to keep it somewhere. So you use it later. So you keep that water. For example, if your father brought back water, you keep that water in a container meant for water. So here you scan the value, take the value from the user, you keep it, because the computer needs every information possible, because it's a computer now, it's not that intelligent. And when you are assigning, I think the only thing that is left here is assigning. When you have to assign something, like 2 is equals to a or something, a is equals to 2, if you are doing math. In algorithm here, you use an arrow to assign a2 to a or a to 2. So that's just the basic one. So as from this beginning, I just write a simple program called Hello World. I don't know why they always write that program when it comes to programming, but that's the main program they normally write. So now I'm going to write a simple algorithm called Hello World. So while writing an algorithm, we start by, as I said, the structure of an algorithm. I'll go the name of an algorithm, Hello World. Hello World. And don't forget, I try I'm the one to forget it. And algorithm, you know, an algorithm is not supposed to have space. So I'm not supposed to forget that. So I don't think this algorithm needs any variable, because variables are like what you use. Like why you say container. I don't need any container. So don't write begin. I will start print. As I said, print semicolon hello world. Then you write your semicolon and you end. Actually, as you can see here, I don't need to scan anything because the user don't need to enter any variable. Here, print, what you are going to see as somebody using the program. Actually, this is what the programmer writes and programmer sees. But the guy using the program behind the screen is not going to see all of this. What he's going to see is only what is inside this print. So print, as I said, just displays. So let me just take for example the output, or what the user is going to see. Let me put it here, output. The user is just going to see hello world. That was all for today's video. We'll talk later for the next video. Thank you for watching. I'm sure you enjoyed yourself. Don't miss the next video. Like, share, and comment. Thank you.